Welcome back to Nick Does Math for a bit of 3D geometry. What do we got? We got line L, well I didn't write it's called L, but I'm going to refer to it as L, with this vector equation. We've got a plane pi which is parallel to this line and goes through these 2 points. Task 1, let's find an equation for pi. So what we want is, ideally we want 2 vectors in pi. Well, if pi is parallel to that, we've already got 1 vector. And another vector will be the vector that joins these 2. So what vector joins these 2? 1 to 5 is going to be 4. 3 to 2 is a -1. 5 to 5 is 0. That's going to be handy. I'm going to take the cross product of that with 2 minus 2, 3. Because what I want is, I want a vector that is perpendicular to both of those vectors. Now you can, without the cross product, you can set it up, just call the vector A, B, C, whatever you want to call it, and you will get some systems of equations that you need to cancel out. I'm going to take the easy route out, I'm going to take a cross product. So Bosch minus 3, Bosch minus 12, Bosch minus 8 plus 2 is minus 6. Now we don't need to have it that way, so in fact I'm going to take my normal vector for the plane to be 1, 4, 2. That feels good. 1, 4, 2. Yep, that seems to work. So the equation for the plane will be dotted with 1, 4, 2 is equal to, I just need to take a point dotted with 1, 4, 2. So let's just take 1, 3, 5 dotted with 1, 4, 2, which in our case here is 1, 11, 23. 1, 13, 23. Okay, i.e. x plus 4y plus 2z is 23. Right, find the distance from the line to the plane. I'm going to actually be a little bit lazy today and use these results that I have. To do that, well, because the line is parallel to the plane, I just need the distance from any point on this line to this plane. So we've got a point on the line, so let's just find the distance from a point to the plane. How do we do that? That is mod. We're going to plug in these things, so minus 7, minus 12, minus 23 over square root of 1 squared plus 4 squared plus 2 squared. So what's that? It's 42 over root 21. Fair enough. 2 root 21. Does that feel okay? Hopefully that's okay. And then find the reflection of L in pi. Now again, let's see. So I've got my plane here, pi, and I've got my line here, L. And if I reflect it, right, all I really need, right, because that is parallel to that, is the direction vector won't change. So all I need to do is I need to reflect 1 point. All I need to do is I need to reflect that point in this plane. Okay, so how do we go about that? Here's how I do it. We first of all create a line that goes through this point. And goes along this direction vector. And we're going to make it intersect with that plane. So we're going to make it intersect with this plane. So minus 7 plus mu, minus 12 plus 16 mu, plus 4 mu has to equal to 23. Now what I'm now doing is, so let's find the value of mu that makes this work. It's minus 19. Ooh. Oh no, I suppose 42, right? 42 is 21 mu. I get mu is 2. So what we're doing here is, I need mu is 2. If you think about this point, I need mu is 2 to get to the plane itself. Well, if we take another mu is 2, we will get to the reflection of the point. So my reflected point will be this. We're going to take mu is 4. So my new point is going to be minus 7 plus 4 is minus 3. Minus 3 plus 16 is plus 13 and 8. All right, so I've now got the new point. I'll do it here. So L dashed R is, that's the point, minus 3, 13 and 8 plus lambda lots. It's still parallel. And there we go. Bit of 3D geometry there. Parallel line to a plane, distances, reflections, all the good stuff. Awesome. Drop a comment below to let me know what you think. If I missed anything there, if you're not sure, we'll try and get back to you ASAP. In the meantime, don't forget to like, subscribe, hit that bell so you don't miss a single one of these as they come out. I'm Nick, and I will see you next time.